Here is another simple problem with great concepts. Set of equidistant points in R3. Question is, determine the set of points midway between points -5, 0, 0 and 5, 0, 0. Write the scalar equation to represent your answer. Now, we are given 2 points which are ordered triplet. -5, 0, 0 and 5, 0, 0. That means we're talking about R3, right? So let me sketch one R3 space. So this is y, x, y, z coordinates, right? This is x, okay, this is y, and that is z, right? Now, the points given to us are -5, 0, 0 and 5, 0, 0. So of course, 5, 0, 0 will be on this side. So let's say 1, 2, 3, 4, 5. So that is our point 5, 0, 0, right? -5, 0, 0 is going to be on the minus side, which is this side, right? So let's say 1, 2, 3. Let me just extend it like this. And so we have -1, -2, 3, 4, and -5. So we have -5, 0, 0 on the other side. Now we need to find set of points, right? So important thing here is set of points, correct? So that means not just one midpoint, right? Of course, the midpoint is right in the center. We can add these values, divide by 2. So we get 0. Add these values, divide by 2. Another 0. So origin is the midpoint between these two lines. Now, what is the set of points which are equidistant from these 2 points? That is what we need to figure out. If you see, any point on this YZ plane will actually be equidistant from these 2 points, correct? Any point, including the axis, correct? So if I take a point here on Z plane, it will be same distance from these 2 points. Or if I take a point here on Y-axis, maybe positive or negative, it is going to be same distance from these 2 points. So what we realize here is that the plane XYZ itself is kind of equidistant. Every point on this plane, so let me just draw a small one here, right? As you know, the planes really extend from positive infinity to negative infinity, right? So it can extend. As you can see, any point on this plane will be same distance from the given points, right? So that is what our solution is. And so we come up with a solution, and that is we have YZ plane, right? So YZ plane is actually the set of points. YZ plane represents set of points equidistant from these 2 points, correct? So that is our solution. Now how to get the equation of this plane from these 2 lines, right? So what we note here is that on a plane, if we give you a point and normal to the plane, then you can write down the equation. So we know what the point is. So we know there is a point on the plane which is origin itself, and that is 0, 0, 0. How about the normal? The normal to the plane is actually the line joining these 2 points. Do you see that? So the line joining this, which is x-axis. So the normal for us is 1, 0, 0. So that is x-axis, which is normal to the plane. Now since x-axis is normal to the plane, we can write down equation of the plane. Equation of the plane is given by ax plus by plus cz plus d equals to 0. So that is equation of the plane, and let me call this plane as pi, right? So this is pi YZ plane. Now to find the values of x, y, z and the equation of the plane, what we can do is, we know a point 0, 0, 0 lies on the plane. If 0, 0, 0 lies on the plane, then what is d? So we can plug in 0, 0, 0 here. So if I put 0, 0 and 0, I get d is equals to 0, right? Since d is equals to 0, So we get ax plus by plus cz. Now what are a, b and c values? Actually speaking, normal gives you a, b and c values, correct? So when we say normal is 1, 0, 0, it is basically a, b and c values, right? In this equation, which is in Cartesian form, normal, the coefficients of x, y, z represents the normal, right? So a is 1, b is 0 and c is 0 for us. So if a is 1 and b is 0, c is 0, then what is the equation of the plane? I can write plane pi as equals to x equals to 0, right? Since b, c are also 0. Do you see that? A is 1, b is 0, c is 0. So x equals to 0 actually represents YZ plane. Do you understand now? So we got equation of a plane from this simple criteria, right? Another way to write this equation could be that we could use two directions and a point, right? So we could write equation in the vector form also. So I'm just exploring and writing that for you. So we could write this equation as pi equals to the point, which is 0, 0, 0, plus parameter, let's say s, along the y-axis, which is 0, 1, 0, and the parameter t along the z-axis, which could be 0, 0, 1, correct? So that could be our equation of the line. Now if I really write this in the parametric form, I can write down what x is. So we'll get what? From this equation, we get x equals to 0, and y equals to s, and t equals to, z equals to t times 1, right? Other values are 0 for z, right? So we get parametric form of this. As you can see, x equals to 0 represents the plane yz, right? Another important thing which we learn from here is that in our Cartesian form of an equation, if some components are missing, for example, here in this particular case, the equation of yz plane is what? Equation of yz plane we found is x equals to 0. Now here you will see that the components of y and z are missing, right? So whenever the components of any particular axis is missing, then the plane is parallel to that axis, right? So you can see here that our plane is actually parallel to y-axis. This line is parallel to y-axis, and the other line is parallel to z-axis. So that also helps to sketch a plane, and it goes through the point which is given to you, origin. So right there in the center, we do have a plane which stretches parallel to z-axis. So actually speaking, z is included in it, right? Because it is on it, since the point 0, 0, 0 is on it, right? So it is along z-axis and also along y-axis. So it is this particular plane which we are talking about, which extends in z direction, that means upwards and downwards, and y direction, which is right and left, right? So that is how the answer, that is how we can represent the set of points midway between the given points, right? I will like you to do the exercise, a similar exercise, where we'll change the points a bit. Let the points for you be, let's say A, be 0, 2, 5, 0. Let's take 0, 2, 5. Instead of 5, let me put 0 itself, and point B as 0, 6, 0, right? So find set of points which are equidistant and justify your equation just as we did. And once you justify your equation, sketch the plane which will represent all the set of points which are equidistant from A and B. So let this be a test problem for you, right? So let me write question 1 for you to find equidistance point from point A and B as given to you. That should help you to understand and visualize how the plane should be and why is it extending in a way it is, that is being parallel to, in this case your plane will be parallel to these two axes, which is x and z axis, and all the points will be equidistant from this set of points, right? So try to do this problem and see if you understand the whole concept, and we'll move on and do some more fundamental questions based on planes. Thank you.